Now, let's convert a proper fraction into its partial fractions. So, well, we have this fraction. And how is it a proper fraction? Well, the degree of x in the numerator is 1, and the degree of x in the denominator is 3, because linear term being multiplied with a linear term and that being multiplied with another linear term, well, that gives you a cubic equation, and the highest power of x in a cubic equation is 3. So 1 is less than 3, so this is a proper fraction. However, in this particular example, you can see that we have constants as letters. So this will become a little bit more confusing, but bear with me. Well, as you know, we discussed the first type of partial fraction resolution, and we'll apply that over here. We'll resolve this one fraction into a sum of 3 partial fractions, and in each partial fraction, we'll have one of these 3 terms. So x minus a in the first one, x minus b in the second one, and x minus c in the third one. And they will have a, b, and c as the numerators. Now, we'll take the LCM of these 3 partial fractions. So basically a will be multiplied with x minus b and x minus c, b will be multiplied with x minus a and x minus c, and c will be multiplied with x minus a and x minus b. So we'll get this big fraction. Now, the denominators are equal, so the numerators are also equal. The denominators will be cancelled out and we'll just be left with the numerators. Now, we need to eliminate basically 2 of a, b, and c to get the value for one, what would we say, variable, I guess. So we need to find the value of a, we need to eliminate b and c. To find the value of b, we need to eliminate a and c, and to find the value of c, we need to eliminate a and b. So first, let's put x is equal to a in this equation 2. When you put x is equal to a, all the terms with x minus a will be eliminated. So this entire term will be eliminated because this becomes 0 when you put x is equal to a minus a is equal to 0, and this entire term will also be eliminated because this becomes 0. So we're just left with a into a minus b into a minus c. Now we get basically the value of large A, capital A, is equal to a over a minus b into a minus c. Now, when you put x is equal to small case b, lowercase b, in the same equation 2, the terms with x minus b will be eliminated. Now, what were the terms with x minus b? This term will be eliminated because this x minus b becomes 0, and this c term will also be eliminated because this x minus b becomes 0, since b minus b is equal to 0, obviously. So we're just left with the term that has b in it, and this b will become the numerator, and this my b minus a and b minus c will go in the denominator over here. And so b is equal to, uppercase b is equal to lowercase b over lowercase b minus a into lowercase b minus c. Now, when you put x is equal to c in the old equation 2, well, let's see. This term will be eliminated because this x minus c becomes 0, and this term becomes eliminated because this x minus c becomes 0. So we're just left with this term equal to whatever value we have for x, and that is c. So c is equal to c into uppercase c into lowercase c minus a into lowercase c minus b. So c uppercase c is equal to lowercase c divided by lowercase c minus a into lowercase c minus b. So now we have the values for all three uppercase letters, A, B, and C. And when you put that in the equation 1, we get this big equation. These are the three partial fractions. And so that's how we've resolved the question.